Hello, geometry classes. I hope you all are doing well on your time off here in our kind of new normal. Hope everybody's safe. Hope your families are doing well and everybody's safe and staying home during this time. So we're gonna try this. I'm gonna post things here in Google Classroom, some videos with some things. The units that I'm doing are things that we would have normally done at the end of the year, kind of squeezed in, and to be honest are pretty easy things. Like the first two sections we just did, I had you guys work through just areas and perimeters, not too difficult. This one's a little bit newer material, but I thought we'd try this. So my idea here is I'll go through and kind of teach you the concepts and then give you some problems as I go through this video. If anytime you're confused or something, you can pause it and you can go back, replay it if you miss something. Okay, that's the nice thing about it. Also, I probably will ask you to pause it for yourself and try a problem or two out. So you might want to have a piece of paper and a pencil there and probably a calculator as well to work some problems. And then at the end, I'll have some problems for you to try out as well. And I think on this one, I'd like you to kind of turn it in so I can kind of see how you're doing and things like that. I'll probably put up the answers at some point too, so you can kind of check your answers. But I think I want to kind of keep track of who's trying to do some work and things. In terms of grade, I know we're not really grading things, but I want us to really keep working here, and so we don't fall too far behind, so we can at least cover some of the concepts, especially some of the easier ones that you're a little familiar with. The next thing after this would be another area that I think is pretty much plug and chug type of formula work. Okay, but it's things we usually cover in geometry. So, and we may go back and also throw in some things that we did previously and so on. We'll see where this goes, but I want you to try to get used to working through this. If you have questions, send me an email, respond there in Google Classroom. Let's try to communicate and do the best we can here in this situation. All right. Okay. So let's get started here. And begin here talking about some things of perimeter and area of similar figures. I'll probably send you some of this in terms of notes as well, so that you have it there for yourself. So the first thing, and nothing here for you to kind of do right now, no problems here, but we've learned earlier that two similar figures that are the same shape but different size, have a ratio of the perimeters equal to the ratio of the sides. Remember, a ratio would be something like 2 to 3 or 3 to 4. That's what I mean by a ratio of the sides. Well, the ratio of the areas is not the same as the perimeter and the sides. If you can see, it says if two polygons are similar with corresponding sides have a ratio of A to B, then the ratio of the areas is A squared to B squared. So if I used my examples up above, if the ratio of the sides was 2/3, the ratio of the areas are 2 squared over 3 squared, or 4 to 9. Okay, and then, or if I use my other example, 3 squared over 4 squared, then they'd be 9 to 16. Okay, and so that's what happens with area, which kind of makes sense because area is squared units, so it kind of goes along with everything else that we've talked about in terms of area. All right, okay, so just kind of looking through some examples. They're all kind of the same type of thing. They're not too complex, but here's the first one, and we'll kind of go through in steps. Not all of them ask you these steps. They may ask for the final answer, and you have to kind of go through these. So first of all, I have two triangles that are similar. ABC is similar to DEF. We want to know the ratio of the sides. Well, 5 matches up with 10. So I could say 5 over 10, or I could say 10 over 5. Okay? Now, make your life easier. Reduce these fractions. It'll make your numbers a lot simpler to deal with in terms of area and such. Okay? So that's 1 over 2, because 5 goes into both. This first question, ratio of the perimeter, all I want you to understand is these two things are the same. So ratio of the perimeter is also 1/2. Okay, now, ratio of the area, we just talked about that. What do we do? Well, according to that, I'm going to run out of space, so I'm going to put it over here. Okay, is, 1 squared to 2 squared. So that makes that 1 to 4. That's the ratio of my areas. Okay, so what that means is the area of this triangle, and if I put that area as a ratio to the area of this triangle, it would be a 1 to 4 ratio or fraction. Okay, now what are we going to do with that? Well, we're going to use this to solve for that. Okay, so what it says is find the area of triangle, or it says area of triangle ABC is 15 centimeters squared. We want to know the area of DEF. Well, you're going to use your ratio, 1/4, and we're going to set up a proportion. Remember, we did this a while back. All right, now what you need to look at is this is going here from small to big. So when we do this here, this should be the small, right? The small triangle. Yeah, sorry, I have to fix some things. So this should be the small triangle up here, and then this is the big triangle. Okay, so which one's the small, ABC or DEF? Well, ABC, so that one should go here, and this will be our X. All right, so if we cross multiply, then we get 1x, and kind of run out of space. Well, let's do this here. I got room. If we do this, and we cross multiply to solve, we get 1x equals 60, or x is 60. So that means the area, that means the area is going to be 60 centimeters squared. Okay, so it's all about coming up with this area ratio and then setting up a proportion. All right, so let's look at the next example here. And yeah, we got that spaced out good. All right, so this one, it's using the perimeter. The perimeter of ABC is 16 feet. Its area is 64 feet squared. The perimeter of DEF is 12 feet. Given that these two triangles are similar, find the area. All right, so I'm just going to draw little triangles here. So ABC and DEF, you can see DEF is smaller. It really doesn't matter. I'm going to make, oh, this is a lovely triangle. Wow. ABC. And then, we're going to make DEF over here a little bit smaller. DEF. In this case, I don't know any of the sides like the last problem, but in this case, I know the perimeter is 16, and here the perimeter is 12. I also know the area is 64. Okay, and yeah, that is feet squared. We'll worry about that in a minute. So, first thing we want to do, we want to get a ratio of the perimeters, ratio of the sides, do that ratio. So it doesn't really matter if I do ABC to DEF or DEF to ABC. Okay, so we're going to do 16 over 12. And we need to reduce that. Well, 4 goes into both of those, so that's 4/3. All right, now we want to come up with our ratio of our area because we're going to figure out that area. So the first thing we do is we take this 4/3 and we square both of those. So that's going to be 9/16. All right, now we have to set up a proportion just like we did in the last problem. 9/16 equals a ratio of the two areas here. Okay, so I have this backwards. Anybody else see my mistake? I just goofed up. Wow. I'm 2 steps in my head trying to talk here. Let's erase. Let's erase. Hopefully you caught on. Hopefully you were screaming. You should have been screaming at me. All right. This is backwards. Dun, 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 dun. So this should be 16 over 9, and this is 16 over 9. That's better. Okay, the reason that mattered, the reason I caught myself is I noticed that we originally went from, the big to the small. And so that has to be the same here, big to small. All right, so what's the big triangle's area? Well, that's 64, and we want to find the small. All right, so we've got to cross multiply here. All right, so when we cross multiply, we get 16x. 9 times 64, I don't know what that is. Let's see. 9 times 64, 576. So that's 576. And then we divide, definitely I don't know what that is. So divided by 16 is 36. So that means the area of the smaller one is 36 feet squared. Okay, and notice we found that area without knowing any of the units or any of the sides. All we needed to know was the ratio to figure those things out. All right, so I'm going to have you try one. I didn't have to minimize that. So I'll have you try that one. I would suggest pausing it, so take a moment and pause. Okay, so let's go through this. It says write the ratio of the perimeters. Well, the ratio of the perimeters is the same as the side, but it wants to go from red to blue. So red to blue, that would be 8 over 12. Let's reduce that. Okay, so 4 goes into that. That is going to be 2/3. Okay, so the ratio of the perimeters is 2 to 3. Now it wants the ratio of the areas. All right, well, what are we going to do with that 2/3? What do I have to do? Well, I have to square both. All right, so 4/9. All right. All right, so that's just using that kind of concept that we just talked about. Now, you know, there's other questions we're going to ask you here, and there's something else we're going to do here to finish up. The last part is we're going to kind of go backwards. In other words, I'm going to give you this, and you have to give me that answer. Okay, and we're going to use that then to solve some things. So let's take a look at the last one. All right, let's see if we can squeeze this in. All right, and so find the area of the blue triangle. All right, well, that's to find that area, right? What do we do? 10 times 15. We just talked about that in the last problem. So that's 150. Okay, now ratio of the areas. All right, so let's go blue to red. So that would be 150 over 96. Okay, now we have to reduce that. Well, I don't know off the top of my head there. Let's see, 2 goes into both. That's 75 and 48. Let's see, what else goes into that? 3 does. So this is 25 and 16 ratio of the areas. Now, I will tell you that these numbers here are going to be fixed so that I can easily answer this next question. All right, so if the ratio of the areas is 25 to 16, we have to know the ratio of the sides. Remember, this is an a squared over b squared, and I want to know what a and b are. Well, we just take the square root of each of these numbers. So what's the square root of 25? What times what gives me 25? Well, 5. What times what gives you 16? 4. Okay, so that's the ratio of my sides. All right, so what we're going to do with that is we are then going to take and set up a proportion. Oops, I need to scroll that back up so you can see the picture. All right, and we're going to set a proportion to solve for the x and the y. All right, so what does that look like? Well, this was blue to red. Okay. All right, and so we have to, and I realize here now that this needs to go up just a little bit more. All right, so then if we go blue to red, we can see that the blue was 15 matches up with the x. Okay, so then we can cross multiply. Oops, I don't mean that. All right, and then we can set up the other one as well. All right, the other one as well would be 5 to 4. Oops, that's supposed to be a 4. Sorry about that. Equals, this would be 10 over y. Okay, so now we have to finish that problem. We have to cross multiply and solve that. Now I have to stop here for a moment. I'm gonna have to make a second video for this lesson because I only have so much time on this video. It's something that, you know, work with me here in the future. I might change this, but for now, so I'm gonna stop this one right here. Okay, if you want, you can finish these two proportions, and when I start the next one, we'll do that, and then we'll talk about, we don't have much else to talk about, but a couple things.